All right, well, greetings, followers. I am honored today to be joined by Dr. Simon Lee. Now, Dr. Lee has his PhD, and he has been studying in the area of stratospheric polar vortex forecasting, which does impact the weather across the globe, especially northern hemisphere, and as well as parts of the East Coast as well. So we are honored to have you. Thank you so much for joining us today.
Thank you. No, it's a pleasure to be here and to discuss.
So can you give me a little bit of background information, like on your education and the research that you did for your PhD, as well as where you are currently residing in the U.S. in your current position?
Yeah. So, as my accent gives away, I'm from England originally, from the north of England, where the weather there probably first inspired me to get interested in meteorology. And so then I went down to the University of Reading, which is in the south of England, about 40 miles west of London, for my undergraduate and PhD, both in the Department of Meteorology there. And then upon completing my PhD late last year, I came out to Columbia University to work in the Department of Applied Physics and Applied Mathematics on similar sorts of large-scale climate and weather variability in the stratosphere and trying to get a better understanding of that. And so that's really been the focus of most of what I've been doing over the last few years, especially kind of looking at this 30 to 60 day sub-seasonal variability and trying to characterize that. And quite a lot of that looking at North American weather.
And can you tell us a little bit about the stratospheric polar vortex and what it is and why it's so difficult to forecast months in advance, even with the technology that we have today?
So the stratospheric polar vortex, so the stratosphere about 10 to 50 kilometers above the ground, you can convert that into miles for the,
right.
for the American units, is this kind of large scale circulation that sits over each pole during the winter. So it's a common feature in the Northern Hemisphere. It forms around September time and it persists, reaching peak intensity around January, February time. And then it dissipates usually in April or May, sort of with the seasonal cycle. And it forms because the pole during winter is much colder than the equator because it tilts away from the sun. So you get this mass of cold air that forms and is encircled by this strong westerly flow, this strong westerly jet in the stratosphere. And that's the stratospheric polar vortex. It's actually important to talk about that precursor word stratospheric, because there are different sort of types of polar vortex. And sometimes we talk about things called tropopause polar vortices, which are small scale weather features that sit on the boundary between the troposphere and the stratosphere, or the tropospheric polar vortex, which is more the weather circulation that we see near the surface, the tropospheric jet stream. And really one of the reasons that the stratospheric polar vortex is so hard to forecast weeks in advance or months in advance is because it's influenced by the weather variability that's going on in the troposphere below it. And that's fundamentally limited in how far away we can predict those specific weather features. And so that somewhat limits how much we can predict this variability higher up. But what is good about the stratospheric polar vortex from the perspective of thinking in longer range predictability is that it tends to vary much slower than the weather systems that we see down near the surface. So if we have a particularly strong vortex, it's actually likely to persist as a strong vortex for about a month. And the same for if it's very weak. So that does mean that when we have these particularly strong or weak events, we have that kind of extended horizon of forecast skill.
And so when the stratospheric polar vortex is very strong, does that mean the winds around it are going very fast, at a very fast, like rapid motion? And when it weakens, the winds tend to relax a bit. And it's that period when the winds relax, when the colder air, if the stratosphere polar vortex influences the troposphere, some of that colder air can seep down into the northern hemisphere. Is that correct? It's the weakening of the polar vortex?
Yeah, I like to think about it. I think the good analogy is thinking of it like a spinning top, and imagining if it's spinning top's going really, really quickly, it's a very stable state, and there's not much undulations from side to side. Whereas then, as it starts to weaken, you get this vacillating behavior, and it's that sort of leads to these big meanders in the jet stream that lead to these plunges of cold air from higher latitudes to lower latitudes that we see with an increased frequency in parts of the Northern Hemisphere when the vortex is weakened.
So when we get into the period when the stratospheric polar vortex initially develops late in August and early September, and we start to see some sort of a trend with the polar vortex, let's say it starts out in September where the winds are slightly weaker than average, maybe in through the first part of October, can that help you predict what might happen later in the wintertime?
It's a good question, and it's one that we've sort of been thinking about a little bit. It's probably not the case that it does at that stage, because things can change very quickly in that spin-up period. But there is possibly this idea that if the vortex is really weak early on, that then if the forcing from the troposphere or whatever, the wave forcing that's causing the vortex to be weak early on, if that relaxes or is otherwise rebuffed by the state of this vortex, that then the vortex can strengthen into the middle of the winter. So actually you kind of have this anti-correlation. And if it starts out strong, and it's so strong that it's essentially shifted forward in time, so that it's so strong for, say, a November vortex that it's effectively a mid-December vortex, that then maybe you can have a stratospheric warming earlier because you kind of shifted your seasonality. But whether that's actually useful in a predictive standpoint, I don't particularly think so, because there's so much going on, but it can help you sort of understand some of the dynamics at play.
And now, even if there is a stratospheric polar vortex warming, which a warming means the vortex itself weakens, it doesn't necessarily mean there's going to be a huge cold outbreak somewhere in the Northern Hemisphere for an extended period of time, correct?
Yeah, so it's kind of, in some ways you can think of it a bit like a changing climate. It's just a background driver that shifts things in a certain direction and shifts you if you imagine a sort of a probability curve, it just shifts that curve toward an increased risk of these cold air outbreaks. But it doesn't just specifically guarantee one specific weather pattern. And really you can think of the troposphere beneath the vortex as being able to do its own thing. It's got other ways of being driven, things like the Madden-Julian oscillation in the tropical Pacific that can influence these large-scale modes of variability. Things like El Nino and La Nina, they can have their roles to play. And the stratosphere is just one hammer on the troposphere. So lots of other things can come into play.
Yeah, for example, this past winter, that is the 2021-2022 winter, we saw the polar vortex was unusually strong, yet North America had some cold outbreaks, and that was driven to other patterns in the troposphere, and I guess some connection with the Madden-Julian oscillation as well, right?
Yeah, we had this particularly strong pattern through December, where we had a ridge in the North Pacific and this very negative PNA pattern that persisted for almost the entire month of December. And that was remarkable. That kept us nice and warm in the east. Frustrated me as I just moved here and was hoping for snow and didn't get any. And that's really consistent with the vortex being strong at the time. But then as we sort of shifted into the new year, we had this ridge build up toward Alaska, and that kept things much colder east of the Rockies. And really understanding more about this Alaskan ridge regime has been a focus of some work I've been involved with recently.
Okay. Yeah, because you normally get the warm outbreaks across Alaska, and then the colder air tends to dive in the east. Now, I did read some of your research, and there's perhaps some correlation with if it's the polar vortex very strong during the winter, it can have a dramatic cool or warming, the final warming in the spring, and that could potentially set up a pattern that drives an unusually cold weather pattern during the spring. Is there some correlation there between a very strong midwinter stratospheric polar vortex and a dramatic warming later in the spring that creates some sort of a cold outbreak in the northern hemisphere?
Again, dynamically, there is good reason to think of that. So to really to get a so let me backpedal a few steps. So if we think about as we move into the spring, sort of naturally speaking, without thinking of wave forcing of the vortex in the troposphere, because of solar radiation getting to the pole, the vortex will just begin to weaken and decay.
Mm-hmm.
And that actually makes it less susceptible to having one of these dramatic warming events, because to get one of those, you actually need quite a strong, sharp vortex edge. You need it to be in a state that's called preconditioned usually, and receptible to this sort of warming event. And so if you have a strong vortex through the middle of the winter that persists into, say, February, early March, that's in a better state to then have one of these late warmings than if it had been disrupted early on or had just been otherwise weakening. Then it would be harder to get. It's essentially like that same idea I mentioned earlier, in that these late final warmings, you can almost think of them, these early final warmings, you can almost think of them as late midwinter warmings.
Okay.
They're really in the same ballpark. And so we've had one of those this winter, which to all intents and purposes looks like a midwinter warming. It was just in March rather than in January or February.
So where do you see the field of stratospheric polar vortex research 10 years from now? And what do you hope comes out of the current research being done in terms of being able to forecast the strength of the polar vortex through the winter?
So I think we need a better understanding of these cases so one thing is when we've had some kind of vortex event, it's still currently difficult to understand when and why we might see a very strong coupling between what's going on in the stratosphere and what's going on in the troposphere. When we have something like a very strongly negative Arctic oscillation in the stratosphere, whether or not the troposphere is in the same state. And if they are, what you can get is a so-called window of opportunity, a situation where you pretty much know what the forecast is going to be in 3, 4, 5 weeks ahead. And then a good example of that was during the winter of the early part of 2020, when we had a very strong vortex in the stratosphere and it was super well coupled to the troposphere. That was an example of a window of opportunity. But in contrast, you can have other situations where it's not quite so well coupled, and actually probably the winter just gone is an example of that. And so understanding what it is that leads to those two cases, maybe there isn't a specific answer, but I think being able to say, we know that we're in one of those scenarios, that would be really amazing to achieve. But that's sort of after you've had the event. In terms of actually getting to forecasting the event, I think we just need better ways of understanding what's going on in the forecasts at weeks ahead of time, because we have an increasingly large number of forecasts available, increasingly frequently, and there's all these ensemble members in the forecasts, all this spread and all this uncertainty 3, 4 weeks ahead of time. We need better ways of kind of interrogating those ensembles, looking at them, and as a forecaster being able to pick out what's going on and maybe create storylines where you can say, if X happens, it looks like Y will happen, and then we'll see this forecast. Because at the moment, if you're just relying on the ensemble mean, I don't think that's really going to give us enough useful information to actually make practical decisions 3, 4 weeks ahead of time.
Is there one particular forecast model that seems to do a better modeling of the stratospheric polar vortex through the winter early on?
Early on. So we've recently got a paper which is under review, and hopefully will be out soon, where we investigate a set of different forecasts and look at the biases in them. And generally, there are quite a few common biases across these models where they struggle to either simulate wave activity coming out of the troposphere into the stratosphere, or they have a lower stratospheric vortex that's too cold, and those sorts of things. So hopefully those will again be remedied in the next 10 years as model development increases. But in terms of actually practically looking at the forecasts, it's difficult to say because I've not got the experience of someone who's sat down and made forecasts off these, but also I've not looked at all of them in real time. I have, now that ECMWF produce their forecasts freely, I've got a lot of experience with looking at that. Okay. And I think it is a good forecast system, and it's constantly being improved. So that's the one which I see the most of, and would probably be biased towards saying was doing a good job. It's certainly better than CFS, put it that way.
Yeah, and what Simon is talking, Dr. Lee is talking about, is the various models that we look at for stratospheric polar vortexing. The European model, which is, he referenced CFS, the GFS, which is the global forecast system used. One of the United States models. There's one in France, I believe.
Yeah.
So there's a variety of forecast models. And he also referenced the tropospheric polar vortex, which the news media references occasionally. That's the one that can dip farther south and move across the country. The stratospheric polar vortex, which is the one is more semi-permanent over the North Pole. And when that warms, it can be displaced, but it's never displaced, like, for example, down in New York City or this far of a southern latitude. So
yeah, and I think that's where the message always gets confusing when I'm trying to explain this to people that I meet, is that when I'm saying, well, the polar vortex is very cold, and that means that it's very warm, and that's where people can get lost. And I appreciate that that's difficult. The media don't help this matter at all, and it is confusing, this
it can
term
be
polar vortex, because we expect to see perhaps more polar vortex outbreaks, if you want to call it that, perhaps when the actual stratospheric polar vortex is warmer because of that disruption, as you said. But if I had my way, we would never refer to the tropospheric polar vortex as the tropospheric polar vortex. I don't think we need that name. I think we can just say jet stream, and I think that's enough.
Yeah. Now, another question somebody might have, just a public person, somebody who's just heard terms before and climate terms, is global warming seems to be happening. Temperatures keep warming during the winter and keep warming during the summer. Is global warming going to be a contributor to more stratospheric polar vortex warmings? That could be a question.
It is a good question. It's always a difficult one sometimes because it's sensitive to a variety of factors. I think at the moment, it doesn't appear that there will be a huge change. But that the complicating factor is that we have this actual possibility that it leads to changes in the tropospheric polar vortex, or the jet stream in the troposphere, leading to perhaps increased waviness in that. But it's been a very hotly contested issue. There was a recent paper that was in Science that came out last year, which suggested that sea ice loss was actually leading to a pattern which was causing more vortex stretching events. It was actually associated with a different type of stratospheric vortex variability that was associated with wave reflection, the details of which are not particularly important to get into, but essentially that's almost where the polar vortex shrugs off an upward propagating wave that comes up to it, and that can actually lead to weather patterns in the troposphere that this paper argues is associated with cooler weather, colder weather in the eastern half of the US. So it's possible that maybe we would see more of those. At least that's what this paper was suggesting. But it's a difficult one to get a good idea of what's happened in the last 40 years or so, because we don't have many of these events. You have a very small signal, lots of noise, lots of other factors going on. So it's very difficult to know what's happened in the real world. And then you have models which have problems, and you have various different complicating factors going on there. So it's a difficult question to answer, but there's not something clear cut. Clear cut,
exactly. Excellent. Well, I thank you so much for joining me, and I really think that you nailed the outline for us, separating the troposphere, which is where the weather occurs, and the stratosphere, and how the two interact at times or don't interact to produce our weather. I guess the last question I have for you is, and we just talked about global warming. Is it true that the Arctic seems to be warming faster than areas closer to the equator?
Yeah, so near the surface or in the lowest few kilometers in the
Right.
atmosphere,
Yeah.
the Arctic is warming 2-3 times faster than the global average. As you go up through the atmosphere, the tropical upper troposphere is generally warming slightly faster than the tropical lower troposphere. And that's another complicating factor that maybe our observations are insufficient to capture. So we have issues with that from the observations of the tropical upper troposphere. Some models seem to overdo the warming in the tropical upper troposphere. And it's this complicated idea that essentially the pattern of global warming has not just a 2-dimensional variability, but also a 3-dimensional variability. And then the stratosphere is cooling because of increased greenhouse gas concentrations. So that's another matter.
So it is possible that some of these cold, in the future, if this trend continues, some of these cold outbreaks associated with the breakdown of the stratospheric polar vortex when it couples with the troposphere might not be as cold as historically we have seen cold outbreaks.
Yeah, there was a paper that came out last year or this year or at some point recently. Time has stopped making sense to me in the last few years. That was suggesting that had already been happening, because when they essentially damps the variability, because your Arctic outbreaks have warmed faster than outbreaks from other directions, so you have less swings. Yeah, but equally, if you have an increased frequency of those types of weather patterns, then you can damp the warming trend at a certain location by having a change in the circulation. So there are various ways.
Excellent. Well, thank you so much for breaking this information down for me. And I appreciate you sharing all of your knowledge, not only with me, I'm learning as well, but our followers as well with the Hagerstown Town and Country Almanac. And I was giving Dr. Lee kind of an idea of what the Almanac is. We do long-term forecasting that I do here for the Hagerstown Town and Country Almanac with the best of my ability, incorporating some of this information and trying to see if I see any correlations to the patterns in the east, and trying to break down the forecast at least 12 to 16 months ahead of time. So it does help with our folks who subscribe, and especially gardeners and farmers, to get an idea of when the growing season will officially end in the fall and then begin, of course, in the spring season. And some of this information does help, because farmers really do look forward to a period in the winter where there is sufficient snow cover and there is sufficient cold temperatures. And a part of that can be attributed in some years to the stratospheric polar vortex and the state of that vortex. So thank you so much for joining me today, Dr. Lee. I really appreciate all the information that you've shared with our followers.
You're very welcome. Thank you for having me.